Hey guys, welcome back to Algo's Explained. My name is David Kim, and today we're going to go over another LeetCode question. This is one that uses hash tables. I wanted to do a video like that, and so I searched it out specifically. This one also has a solution that doesn't use hash tables, and so you might see it on the screen already. If you're not familiar with what that is, we are going to go over that after we go over the hash table solution, so stick around for that. Okay, let's go over the question itself. Given a non or empty array of integers, every element appears twice except for one. Find that single one. So looking at the examples is pretty straightforward. We have numbers that are duplicated and one number that's not going to be. We also know that it's guaranteed that it's going to be non-empty. They even bolded it for us. We know that every element is going to appear twice except for one. And so we probably wouldn't even have to error check on that. If you do want to ask your interviewer, should I error check on that, or is there a possibility that there are multiple ones without a partner? They might say yes. They might say yes, just give me the first one or give me any one of those single digits. But those are some twists and turns that you might want to mention just to let them know that you're thinking ahead and out of the box and thinking about edge cases. For a longer example here, we have the 4, that's single. We have the 1, 2, 1, 2. And before we go over to the hash table solution, I kind of want to talk about a thought process in which that I follow, not just for this question, but for other questions that kind of helps me get to the solution. And that one is kind of, how would I do it in real life? Like, don't even think about algorithms. How would I do it? And right when I was explaining this example for you guys, I just straight up said 4, there's a single 4, and then I said 1, 2, 1, 2. But how do I know that there's a single 4? Well, it's because the array is so short that I can see it in one glance. But imagine somebody was just saying these numbers to you. Instead of them saying, okay, look at the array, give me the one give me the one without the pair, they might read you the numbers. And in that case, how would you keep track of it? You would think, okay, I heard a 4, and I only heard it once, of course. They gave me a 4, and so in my mind, I'm storing that. I'm saying, okay, I heard a 4 once. They say 1, and so now, okay, I heard a 4 once. I already knew that. I heard a 1 once. They say 2, same thing, and then they say 1 again, and you say, okay, oh, well, I heard that before, so now I've heard that twice. Kind of you update that number in your head. Okay, I heard 1 twice. They say 2. Now you say, okay, I heard 2 twice, and they say, that's it. Give me the one you only heard once. And you say, okay, which one of these? Okay, I remember I heard 2 twice, I heard 1 twice, and 4 I only heard once. And so that's the number you give them. And if you were to do that in code, how would you do that? It would pretty much be using a data structure to keep that for you in your own mind. And so using a hash table in this sense would be the perfect data structure, simply because we need to keep track of numbers and how many times we use them. And so we kind of need that key value pair. We need to know a key, and we need to know some kind of description or some data about that key, which is the number of times we heard it. And so using a hash table for that situation is perfect. We're going to go over the solution without any extra memory, but just to, that is kind of the standard solution that most people would first think about and usually give. If we look over here, this bottom part, lines 37 through 53, this is the solution that uses the hash table or a map or an object, however you want to call it. It's the same thing. How would we do that? We use the map. Again, the key value pair, the key would be the number and the value would be how many times we've heard it. And so in order to do that, we need to, first of all, we're gonna need to hear all the numbers. And so that would be in the format of iterating through the nums or through the parameter, whatever they're gonna give us. And as they tell us that, we need to update in the data structure as we were updating in our minds, how many times we've heard that. When they first start, you haven't heard any numbers, so your map is empty. And when they say, okay, 4, you think, okay, is this in my map yet? And that's what this line is checking. Okay, is it undefined or not? If it is, then, okay, we heard it once. And if it wasn't, that means we've heard it before, and so we just increment the value that was previously there, most likely a 1. If they're giving us double pairs, then it will be a 3 and go to a 4, or however they want to do it. After we finish creating that, um, imagine, I guess for an example this short, you would know, okay, I only heard 4 once. You'll know it off the top of your mind, but if they were to give you so much, and literally so much that you had to write all these down, then you would have to kind of look at the list again and say, okay, which one of these had just 1 in it? And that's kind of what's happening here, lines 48 through 52. We're going through the map again, and we're checking, okay, which one of these had just 1 of them, and the one that had the num that had only 1 as the value, that's our guy. That's the one we're going to return. And because it didn't have a pair, it never came up again. Therefore, we were never able to increment it to anything else. And so that is the solution using a map. Let's go over the solution not using a map or not using any extra memory. And if you thought after reading this note here, because they want us to not use extra memory, I might have to sacrifice the time complexity a little bit. You're not wrong to think that, because oftentimes that is exactly what happens. You take away some space complexity, but you gotta run it a couple more times or something like that. In this case, you don't, and so we're gonna go over the solution that allows us to not sacrifice anything. All right, so we have the solution here next to us. It is using this operator, XOR. And if you're not familiar with that, it is a bit manipulation operator. And before I even mentioned that, if you were at this question and you thought, I just need the tiniest hint and I might be able to get it, I don't want to look at the solution. Pro tip, you can go over to the description side and click on related topics, and it'll kind of tell you, okay, like maybe you got to this question by clicking similar questions or something like that, and these guys, there's no hints here, and just by looking at this question alone, you wouldn't have known off the bat this problem targets hash tables. But if you wanted like an extra hint, related topics, this will kind of tell you in the realms of what they're looking for. And so we already took care of the hash table. The second hint would have been bit manipulation, and maybe if you heard that, you might have thought, okay, I can use XOR, that's going to be my solution. But anyways, yeah, pro tip there. If you need just the tiniest push, related topics, but if not, I encourage you to spend a reasonable amount of time on these questions, not too long, because the more you see, the better you're going to do, honestly. And just look at the solution and prepare for the next one and do these over again sometimes. Anyway, so the operator is called XOR. If you're not familiar with it, we're going to go over kind of what it does. But just for the sake of algorithm, we're setting a num variable to 0, and we're comparing in the for loop, which goes through the array here. We're comparing it against the num against the number that we are at. And then in the end, we're going to return num, and we're just relying on this XOR to kind of filter out all the numbers that are duplicated and leave the one number that has not been duplicated. And the way XOR kind of does that is, how does it filter out numbers that are duplicated? Well, XOR in binary format kind of compares numbers against each other, and it will flip the switch on the column that is different. If it's the same, it'll remain a 0. And so, like, take a look at this 2 against the 2. Since these numbers are exactly the same, represented this way, everything's a 0. But since the 0 and the 1 are different, well, we'll look at the columns that are different. And since this first column was different, we'll add a 1 in there. Since the rest of the columns are the same, they stay the same, and it is a 1 that's represented. And so pretty much looking at the 2 and the 2, we know, okay, XOR really does filter out numbers that are the same. And so what happened here is we're taking the num, we're initializing it to 0, we're XORing it against every single number in the array that we're given, and then at the end, we're just relying on XOR to have filtered out all the duplicates and leave that one number behind. And so let's go over the 221 question here. As you're looking at this, I want you to think the top column or the top row as the what is represented by num, and the bottom one as what is represented by the number in the array that we're looking at. And so 0 is num right now. We had it initialized to 0. And so num against the 2, which is what is happening here. Num against the number that is in the array, and then we're making the num that value. And so the 0 against the 2, let's look at which columns are different. The first column is the same, we leave that as 0. The second column is different, so we flip that on. And then the rest are the same, trailing zeros. And so num is now equal to the representation of a 2. And I say num is now equal to that because we did an XOR equals. Same thing as like plus equals or multiply equals or minus equals. It is doing the XOR and it's resetting the num to that value. And so now num, so this 2, don't be confused by the 2 and the 2. This 2 is actually a num. We're XORing it against the 2, and then that equals the whole 0. And then now num equals a 0. We're XORing that against the 1, and now we are at a 1. And then here, just because I think this solution is a little bit, or this example is a little bit more interesting. Let's go over this one. We have a 0. Num is 0, of course. We start at the 0. We compare it against the 2, and it becomes a 2. We already knew that from this one. Now, the next value in the nums array is a 1. And so the num against the 1. And we kind of look at it, okay, first column is different, so we flip that on. Second column is different, and so we flip that on. The trailing zeros are the same, and so now num is XOR equal to this guy, which is a 3 right here. And so now we do 3 XOR 2, and we're not claiming that there's a 3 anywhere in this nums array. We're just letting XOR do its thing. And so now 3 XOR 2, we're going to look at it. Okay, the first column is different, and so we're going to flip that on. Second column seems to be the same, right? It doesn't matter if it was a 0 or a 1, it's the same, and so we're going to flip that back off. It's the same. And then the trailing 2 zeros are the same. And so now num is equal to this value, which is a 1, and it just did num against a 2, which was the last guy. And so now we are left with what num is what it is, and right now it represents a 0, or sorry, it represents a 1, which is correct in this situation, and then we return it. So, and let me leave you with this. XOR is spelled like that. And so hopefully this helped you out. This is the bit manipulation solution that doesn't use extra space. We still use a linear runtime because we had to go through the nums array, and there really isn't any solution to go beyond that unless, yeah, I don't think so. But this one certainly helps us out with the space complexity. And so hopefully this helped you out. If you enjoyed the video, be sure to like, comment, and subscribe. And I'll catch you in the next one. Bye.